This is the Math 2 Unit 9 review worksheet. This unit focuses on factoring polynomials. So we're going to start off with simplifying, and if we notice, we're adding two polynomials together. So this is what we call combined like terms. I have a 4x squared and a 5x squared, which together give me 9x squared. I have a 9x and a 2x, which together give me 11x, and I have a negative 1 by itself, so I just bring down the negative 1. This gives me 9x squared plus 11x minus 1. For our next problem, it's a very similar problem, but now it's subtraction. So what I like to do here is take the negative and distribute it like a negative 1 to both terms. So that becomes minus 6x to the third minus 2y. Now for my like terms, I have 4x cubed and negative 6x cubed, which gives me negative 2x cubed. And 9y and negative 2y becomes a positive 7y. For number 3, we're combining. We don't want to confuse this with the product rule that we saw in the last unit. If I have 5x to the third and 5x to the third, that gives me 10x to the third. For number 4, similar to number 2 up here, we're going to distribute the negative. So I get a plus 2y squared plus 8y minus 7 in the second part, and I bring down the first part, and now I'm going to combine like terms. There's only one y cubed, so that comes down by itself. There's only one y squared, so I bring that down. I have a y and an 8y, which together become 9y. And negative 1 and negative 7 becomes negative 8. For number 5, the perimeter of a pentagon is 14x plus 9. We have the following sides listed. We need to find the other options that could be the missing sides. Now first off, a pentagon we know has 5 sides. So it's 14x plus 9 equals 4x plus 3x minus 2 plus x plus 5 plus our 2 missing sides. So what we can do, instead of having to plug all of these in and check, I'm going to kind of put this together and see what I'm left with. So I got 14x plus 9 here. 4x plus 3x plus x is 8x. Negative 2 and 5 is positive 3 plus the 2 additional sides. Well, let's go further. Let's subtract 8x plus 3 over to this side and see what I'm left with. So 14x minus 8x gives me 6x. 9 minus 3 gives me 6. So what this tells me now is my 2 missing sides have to add up to 6x plus 6. So now I can go through all of these answer choices and figure out which ones are 6x plus 6 when you combine them. So for example, 5x plus x plus 6 gives me 6x plus 6. That one works. 3x minus 5 and 3x minus 1 is 6x minus 6. That doesn't work. 4x plus 7 and 2x minus 1, 4 and 2 give me 6x, 7 minus 1 gives me a positive 6, that one works. And for the last one, 6x plus 5 plus 1, 5 and 1 give me 6, 6x plus 6, that one works. For number 6, we need to choose all the expressions that are equivalent to the following equation that I have, even if they're not factored completely. So I'm going to kind of work towards what I have here. So I'm going to work through all the other answers and get them to match, see if they match. So I'm going to kind of just work through them here. So 3x times 2x minus 1 squared. Now that means I need to write 2x minus 1 2 times, and I'm going to go through and multiply. Now when I multiply here, you could use a distributive property, double distributive property, also known as FOIL. Or you could the area and the box method, depending on what your teacher showed you. I'm going to draw out the area model as I do it, but the double distributive will get you to the same result. So multiplying 2x minus 1 and 2x minus 1, I get 4x squared minus 2x, and positive 1. So that means all of this is now 4x squared minus 4x plus 1. By distributing the 3x into that, I now have 12x cubed minus 12x squared plus 3x, which if I look, matches. There's my answer. Now for B, if we notice, it's the exact same as this one, but it's the positives, so 2x plus 1 and 2x plus 1. And because of that, that likely means they're not going to come out the same way. So if I do 2x plus 1 and 2x plus 1, this comes out to be 4x squared plus 4x plus 1, and after distributing, it's not going to work, so b is going to be out. Furthermore, if you look at c, that's difference of two squares. So what's going to happen here is the difference of two squares becomes 4x squared minus 2, or not minus 2, minus 1. And by distributing in the 3x, that's not going to match, so that one's out. For d, what I have here, it looks exactly like what I had on this problem. 3x times the quantity 4x squared minus 2x plus 1. So we know that's going to work, which really brings us to e, which is 1/3 x times 36x squared minus 36x plus 9. I'm going to distribute an x to all the terms and then take a third of the value, or a third of the coefficient. So 1/3 of 36 is 12, and that becomes x to the third. 1/3 of negative 36 is negative 12, which becomes x squared, and 1/3 of 9 is 3. And if we look, it does in fact match. Oops, forgot the x. It does in fact match, so E is also a correct answer. All right, moving on, we're now finding the products, and we'll start with just multiplying these together. It looks very similar to what we did last unit. You're going to do 3 times negative 5 is negative 15. X squared and x squared multiplied as x to the fourth, and y times y is y squared. That's our first step. Now, x minus 6 quantity squared does not mean you're going to distribute in a squared and make it x squared minus 36. That's not what we're doing here. This would need to be multiplication in order to do that, and we call that the power rule. So what we need to do for this one is separate it into two binomials. So we're going to go x minus 6 and x minus 6. Now again, depending on the method you've learned by your teacher, you could do a distributive type method or draw this box for area model. Both come out to the same result. So here I get x times x is x squared, negative 6x, negative 6x, and positive 36. I can now add the diagonals, x squared, negative 6x and negative 6x is negative 12x, and 36. Same idea for number 9. It's 2x minus 3 and 2x minus 3. Two x times 2x is 4x squared. 2x times negative 3 is negative 6x, also a negative 6x, and then positive 9. By adding the diagonals, I get 4x squared. I get negative 12x and positive 9. For number 10, we got x plus 3y times x plus 3y. We get x squared, 3xy, 3xy, and 9y squared. That gives me with x squared, 3xy and 3xy is 6xy, and then 9y squared. For number 11, they're now different terms, but we're still going to multiply. So we got x plus 3 and x minus 1. X times x is x squared. X times 3 is 3x. Negative 1 times x is negative x. And negative 1 times 3 is negative 3. So that leaves us with x squared. 3x and negative x is 2x. And then negative 3. Last one. We're going to draw our box. 4x plus 5 and 2x minus 7 leaves me with 8x squared for the first box, 10x, negative 28x, and negative 35. So we get 8x squared. 10 and negative 28 is negative 18x, and then minus 35. For number 13, it's now a binomial times a trinomial. So we're going to do the same process. We just add another column or row to our box. So we got 2x minus 3 and x squared minus 3x plus 9. So as I fill them in, 2x to the third, negative 3x squared, negative 6x squared, 9x, 18x, and negative 27. I'm looking at these diagonals. It has the terms that I can combine. So the lead one is 2x to the third. Negative 3 and negative 6 is negative 9x squared. 18 and 9 is 27x, and then negative 27. Same idea for the next problem. A 3 by 2. We get 3x squared minus 2x plus 1 gives us 3x cubed, 6x squared, minus 2x squared, minus 4x, an x, and a 2. Now with our diagonals, we got 3x to the third is our lead term. Negative 2 and 6 gives me 4x squared. Negative 4x and x gives me negative 3x, and then plus 2. So next we have write an expression that is equivalent to the following binomials. We are factoring. These are difference of squares, so we should recognize that I can take the square root of y squared and the square root of 49, and it's subtraction. When that occurs, it's going to become y minus 7 and y plus 7. Now the reason that works, if we take the area model we just did up here, and we got results of y squared minus 49, they would probably end up right here and here, with these values becoming 0 because I don't have a middle term like I did on the other problems. For that to work, this would be y times y and negative 7 and positive 7, which would give me 7y, negative 7y, which makes them 0, and so my factors are those terms. And that's just a pattern that exists. If you recognize the pattern, you're good. If you need to think of it in terms of an area model, you could use that to help your factoring. So we go to 16 and we look at the square roots again. It's going to be 1 positive, 1 negative. The square root of 16x squared is 4x, so those are my lead terms. The square root of 25y squared is 5y. Those are my last terms, and there are my factors. Now we go on to just kind of general factoring. For number 17, we need to first look at factoring. It's not a trinomial, but they do have something in common. They both have an x squared. So when I take that out, or what we call a GCF, that leaves me with 8x plus 3. 8 and 3 have no common factors. There's only one x left, so this is factored completely, our method being GCF. For number 18, if I look at 10 and 15, they both have a 5 as a factor. X squared and x to the third, they all have at least x squared, so I can take that out. Y and y squared, they all have at least a y, so I can take that out. So in terms of GCF, that's my answer, but now I need to write what's left over. 10 divided by 5 is 2. I took out both x squareds, I took out both y's, so it's just 2. Minus 15 divided by 5 is 3. I had x to the third, I took 2 out, I have 1 left. I had y squared, I took 1 out, I have 1 left. There is my factored form. For number 19, we have m squared minus 4m minus 32. Now, you might have seen different methods as you go through this. I'm going to do factor by grouping, which is a method that you have. If your other methods that you've done are different, at least check to make sure you're getting the same end result, because all factoring should give you that same answer. So for this, I'm going to do 1 times negative 32. So I'm looking for something that multiplies to negative 32 that adds to negative 4. Now negative 32, I'm thinking of like 8 and 4 could work. One of them has to be negative because it's a negative product. And I'm probably going to want the bigger one to be negative, because if it's negative 8 and positive 4, they're going to add to be a negative 4. So that's what I'm going to take, and I'm going to split negative 4m into these two values. So we got m squared minus 8m plus 4m minus 32. So I haven't added anything, I've just split this up. Now that I have that, I'm going to factor the first two terms and take an m out, because that's a GCF, leaves me with m minus 8. And in the last two terms, I can take a 4 out, which also gives me m minus 8. Once I have that, and you got to make sure these match, I'm good. I'm going to take m minus 8 out of both, which leaves me with m plus 4, and there are my two factors. So that's the process on factor by grouping. That's how we get to it, and that's what I'm going to use on the rest of them, but we'll just kind of start to see how that process goes to factoring. So next, we got multiplies to negative 72. That adds to 21. So if it is negative 72, one's positive, one's negative, and we want them that they are 21 apart, so a sum of 21. So that means the bigger one's positive. If we did 24 and negative 3, that would add to 21. And that multiplies to negative 72. So we're going to go d squared plus 24d minus 3d minus 72. First two terms, I can take out a d. Leaves me with d plus 24. I then factor out a negative 3. It leaves me with d plus 24. They match. Take out d plus 24. Leaves me with d minus 3. For number 21, multiplying to 60, that adds to 19. I can do 15 and 4. It's a positive product and a positive sum, but they're both positive. So I'm going to split the middle term. We get w squared plus 15wx plus 4wx plus 60x squared. The first two terms I can take out a w. That leaves me with w plus 15x. Now I know I have extra variables here. I just want to make sure they match. So 4wx plus 60x squared. I can take out a 4x from both of those. That leaves me with w plus 15x. They match. That's good. So my w plus 15x comes out, and it leaves me with w plus 4x as my factors. For number 22, multiplies to 63. That adds to 16. Well, 63 is 9 and 7. Those add to 16, so I'm going to go with those. X squared plus 9x plus 7x plus 63. X squared plus 9x has an x in common. Leaves me with x plus 9. 7x plus 63 has a 7 in common. Leaves me with x plus 9. Those match. X plus 9 and x plus 7. For number 23, 5 times 14 is 70. And then it adds to negative 17. Now if it's a positive product but a negative sum, it'd be a negative times a negative. And the two negatives that would work are negative 7 and negative 10. So we're going to go 5z squared minus 7z minus 10z plus 14. I can take out a z from the first two terms. It leaves me with 5z minus 7. In order to get this to look like 5z minus 7, I'm going to take out a negative 2, and that leaves me with 5z minus 7. 5z minus 7 is common. That comes out, and then I have z minus 2. For number 24, 2 times 15 is 30, and they have to add to 13. That's going to be 10 and 3. So 2w squared plus 10w plus 3w plus 15 is what I'm looking at. I can take out a 2w. It leaves me with w plus 5. I can take out a 3, which also leaves me with w plus 5. They both have w plus 5. And I'm left with 2w plus 3. And there are my two factors. Now for 25, we change it up. We now only have two terms, but again, we notice they're both perfect squares. So this is going to be difference of squares. The square root of 4a squared is 2a. One's positive, one's negative, and then the square root of 25 is 5. For number 26, again, two terms, they're both perfect squares, and it's subtraction, so it's a difference of squares. X squared is 5x. The square root of 144 is 12, and there are two factors. For 27, factoring a trinomial, but before I do that, I'm going to notice they all have a GCF. I can take a 2 out. And I do that, it leaves me with x squared plus 2x minus 15. Now I'm just going to kind of leave that 2 out in front. It's going to be in my final answer because I realize it's going to be probably two binomials. But get that out, and then it's going to make it easier to factor as you go through. So what multiplies to negative 15 that adds to 2? 5 and 3 give me 15. If I make one of them negative, and I go with positive 5 and negative 3, then that meets both conditions. So let's split that. So x squared plus 5x minus 3x minus 15. We take an x out, leaves us with x plus 5. We take a negative 3 out, it leaves us with x plus 5. X plus 5 is what they have in common. X minus 3 is what's left. There are factors. For number 28, we have a GCF because they're all even. And at first look, we think maybe it's 4, but 4 is not. 62 is not divisible by 4. So we're going to factor out a 2. That gives us 2n squared plus 31n minus 16. So I'm just going to put the 2 down here, and then write the two binomials once I get to them. 2 times negative 16 is negative 32. It has to add to 31. Well, 31 is really close to 32, so it's probably 32 and 1 is what I'm multiplying, and I'm going to want a negative 1, because that's going to add to 31, but give me a negative product. So 2n squared plus 32n minus n minus 16. In the first two terms, I can take out a 2n, and it leaves me with n plus 16. In the last two terms, I can take out a negative 1. That also gives me n plus 16. So now, they both have n plus 16. And then the remaining part is 2n minus 1. For number 29, we need to select the expression that is equivalent to this by thinking about the GCF. So I'm just going to first think of a different example to this problem. So I have x plus 3 squared minus x minus 6 and x plus 3. What if we made x plus 3 a and x minus 6 b? I could rewrite it like this. And in doing that, I could say, well, what's the GCF? We'd say, well, they both have an a in common. So I would take that out and write it as a minus b in this factored form. That's what they're asking you to do here, but instead of saying that a number or a variable is the GCF, we actually have a binomial. So now if I look at this and say, okay, they both have an x plus 3. If I took that out, this only has an x plus 3 left because it had 2, and I took out 1. And then this term, which had an x plus 3, now only has an x minus 6. So this would be one of the answers. Now, we should go a step further to make sure the other answer isn't there, but what happens here is if I did x plus 3 minus x minus 6, x minus x, I'm going to write it out, x plus 3 minus x plus 6, this would also just end up being 9. So just in case we want to check, okay, that answer's not there as well. It's not going to work. So we're only going to go with answer C. All right, number 30. Same idea. They both have an x minus 5, so I take that out. That leaves this with 1x minus 5 minus x plus 2, and that's our factored form. Now, for number 31, we're going to multiply this all together. The long way to do this would be to first maybe distribute in and then multiply the binomials. But there's something that happens whenever we're looking at the lead term. The lead term is all of these numbers multiplied together. So that's the 5, the 4, 5x, the 4x, and the 3. So 5x times 4x times 3, we get 20x squared, so that comes out to be 60x squared. The last number is actually 3 times 2 times 1, which would be 6. So our answer here is 60x squared plus 39 plus 6. And what we can do is check. So let's first distribute the 3 in. So that gives me 15x plus 6 times 4x plus 1. And then when I do the box here, getting ahead of myself, 15x plus 6 and 4x plus 1, I get 60x squared, which is that one, and then 1 times 6 is 6, I get that one. So it works for us if we understand how these multiplication comes together. So same on this one. I'm going to distribute the 2 in. I get 6x minus 2 times 2x plus 7. That's 6x minus 2, 2x plus 7. This top box is 6x times 2, which is 12x squared. So that's 12. The bottom box is negative 2 and 7, so that's negative 14, which matches. The other two, it's 2x times negative 2, which is negative 4x, and 7 times 6, which is 42x. 42 minus 4 is 38x. For number 33, we have a square with a side length of 4x minus 3. We need to find the area of the square. Well, a square, that's 4x minus 3 by 4x minus 3. It's just multiplying it together because the side lengths are squared. And I'm just going to draw a square from that to help me multiply. So we get 16x squared minus 12x plus 9. So this becomes 16x squared minus 24x plus 9. Then on 34, we have a rectangle with the side lengths 3x minus 1 and 4x plus 3. And all this is different than 33, is it's just the side lengths aren't the same, but we're still going to multiply 12x squared minus 4x, 9x and minus 3. We get 12x squared plus 5x minus 3. Now for 35 and 36, we're kind of reversing the process we just did with area. So now we're going to factor these to find the possible factors. And that's all it means. It's just going to factor it apart. So the first thing I notice is I have a GCF on these. I can take out an x, and that leaves me with x squared plus x minus 6. So this I know is one of my factors. I'm going to put that there. Now x squared plus x minus 6 is what multiplies to negative 6 that adds to 1. And that's going to be 3 and 2, with the 2 being negative. So x squared plus 3x minus 2x minus 6. I'm going to take out an x, and it leaves me with x plus 3. I'm going to take out a negative 2, and it leaves me with x plus 3. So x plus 3 is one factor, and x minus 2 is the other. That goes along with what I already had, and there are my 3 possible factors. So for 36, we're going to do the same idea, but we're just going to add a little bit more to it. Now we're going to factor out a GCF from the beginning, and it looks like 2x is now what comes out. Leaves us with 3x squared minus x minus 10. So let's put the 2x there. What multiplies to negative 30 that adds to negative 1? I'm thinking 5 and 6, with the 6 being negative. So that's 3x squared plus 5x minus 6x minus 10. I can take out an x, it leaves me with 3x plus 5. I take out a negative 2, it leaves me with 3x plus 5. 3x plus 5 is in common, leaves me with x minus 2. Now for 37, we're going to do the same idea. We have a storage bin with the shape of a rectangular prism, like we had here. And we have its volume, so we need to find the factors. So 2m to the third minus m squared minus 15m. We're going to take out an m, and it leaves us with 2m squared minus m minus 15. So we know m is one of the answers. From here, what multiplies to negative 30 that adds to negative 1? We're going to go with 6 and 5 and make the 6 negative. So we're going to go 2m squared minus 6m plus 5m minus 15. 2m comes out to leave us with m minus 3. 5 comes out to leave us with m minus 3. So m minus 3 is what they have in common. 2m plus 5 is what's left. So m minus 3, and 2m plus 5 are 3 factors. Now for this back page, we need to figure out where the step occurs in the mistake and then correct it. So I'm going to kind of just work through these and see as I go what's happening and see if we can catch it. So we have x minus 5 times x plus 1. So from here, they multiplied them together. If I draw the box, I should have all of the values that they have written in a row in my box values. So I have x squared, negative 5x, x, and negative 5. So x squared, x, negative 5, negative 5x. So we're good there. Now from here, x squared became x squared, negative 5 is negative 5, but x and negative 5x is the mistake. So what we should have, the step 3 is where it occurred. What it should be is x squared minus 4x minus 5. For number 39, I'm going to do the same thing. I'm going to draw my box here. And we have 2x minus 5 and x plus 3. We get 2x squared, negative 5x, 6x, and negative 15. So that's 2x squared, 6x, negative 5x, and this should be negative 15, but it's 3. So there's my mistake. That's in step 2. It should be 2x squared plus 6x minus 5x minus 15. Now that would then become, when I combine these two, 2x squared plus x minus 15. For number 40, we're looking at factoring, and it looks like we can take a GCF first. So we take a 5 out. That leaves us with x squared minus 9y squared, squared on the inside, which, good with that. Then when we do difference of squares, because these are both squared, square roots, we get x minus 3y and x plus 3y, which they did not do. They made them both the same sign. So step 2 is the mistake, and it should have been 5 times x minus 3y, x plus 3y. For number 41, it looks like we can take out a GCF, so I'm going to take out a 2, and that's 2x squared plus 13x plus 21. If we look, that's what they had. So then we need to go through and factor. Well, we know the 2 is going to be there, so let's worry about the 2x squared plus 13x plus 21. 2 times 21 is 42, and it needs to add to 13. So I'm going to split 13 into 6 and 7. So 6x plus 7x plus 21. We can take out a 2x, it leaves us with x plus 3. We can take out a 7, it leaves us with x plus 3. So we have x plus 3 and 2x plus 7. Bring down the 2, and there's our factors, which does not match. So step 2 had the mistake, and we wanted to have 2 times x plus 3 and 2x plus 7. For number 42, we look at this, and this is difference of squares. So as we first take it apart, this is in, it is not difference of squares. Let's back up, I made the wrong mistake. We're multiplying, so we need to split this into 2. So it's 2x minus 5 and 2x minus 5. Almost made my own mistake on a mistake problem. So we're going to multiply. We get 4x squared minus 10x and plus 25. That's not what they have. So step 2 is the mistake. 4x squared minus 20x plus 25 is what they should have had. For number 43, this should split to be 2 times x plus 3 times x plus 3, not x squared plus 9. So that is in step 1, and it should have been 2x plus 3 times x plus 3. If you kept going, it would become x squared plus 6x plus 9 through multiplication, and then 2x squared plus 12x plus 18. Last problem, x to the 4th minus 16. This is going to be a difference of squares problem. So that's going to go x squared minus 4, x squared plus 4. Now, difference of squares needs to be subtraction. So I actually have it again here but not here. So this is done. This one can go further and become x minus 2, x plus 2, with x squared plus 4 staying the same. And there's our factored version.